Hi, this is Ari Everett for CSC120 in the fall of 2023. This is Lab 15, the 3-bit serial adder. On the right is my Logisim and the various devices we built for the lab, and on the left is my write-up. This video is a placeholder. I'll update that with this one when I finish recording it and submit it. We have our learning targets here for the lab, the write-up and problem statement, which was to create a 3-bit serial adder, both chip schematic and the ICs required in the lab. The design process that I utilize going through this with some screenshots from the Logisim on the right here, as well as some supporting material that we had from the lessons that help explain the serial in-out that that data goes through. The Logisim file, and my discussion answering all the questions that were on the lab, as well as my reflection. This down here is the data path control module attachments that I mentioned in the answered question right here. So let's jump into the Logisim to show what I built for this. So the Logisim was built out into 2 parts. The first task was to create this 3-bit shift register, which we got the schematic for the 4-bit. So you can see below, I just made it the schematic for the 3-bit by removing the last D flip-flop. And then from there, I built the 3-bit shift register with the IC required. This is the 74175 with 4 D flip-flops in there. They said not to use the A flip-flop in here, so I'll show you how that works. We created I put in the enable clock here as the on-off switch with an AND gate to make sure that this is to be on when the clock goes. You can see the clock is going. That's because the serial input is not high. Now it is. And let's get the clock going. Let's enter in 111. And remember, it goes from least significant bit to most significant bit by inputting it first on the left. Now I hit the clear and it clears out. And serial out here. We can also put this into automatic mode. Play this here and you can see that goes, and I can kind of in here put 0 and 1 and just kind of guess, but you wouldn't really guess on the number that I'm inputting, but you really would want to do this, especially if you have manual control like this. I'd pause that and do it manually. So let's clear it out, and I'm going to put in, let's say, the number 100 into it, which is decimal 4. So I'd click this once, full clock cycle again, and then hit it high, and then there we go. We have 100 in there. Again, it's confusing. Remember, in serial adding, you go left to right, but the flip-flops are opposite of that, of the MSB to LSB. Now let's go on to the next step, which was the serial adder. I broke this up and then I decided to get into the full circuit because of the different sections that it broke up into, building on each chip. So here's my adder from task 2. Here's my on-off. I put these 3 together essentially to create this. So there's the AND gate from the chip schematic. Here's our 175 chip with the D flip-flops. Here's our 784, or I'm sorry, the 783, which is the 4-bit adder, and then another flip-flop for adding the 2 numbers together. This is quite tricky going from the schematic to the ICs, and I had to do some rewiring between there over and over again to make sure I got it in the right areas. Even the chip schematics on the lab or online were tough to line up with this. I had to zoom in a lot to be able to see the D flip-flops and the clock edge and D, where that is. But once I got that figured out, and then use the open A D flip-flop here for the carry out, and then for the final sum, this 4-digit sum, since it's unsigned binary, that made the whole circuit work here. So we have our various grounds that aren't used for certain inputs, and off we go. One little thing that I did differently is on this clear, I put this NOT gate because I didn't like having a clear active low where you had to turn it on to 1 so it wouldn't clear everything. So I cheated a bit here and added this. You can also add the associated NOT gate IC for it if you wanted to, but I just put the NOT gate on this one thing because that's all we needed. And then I put this momentary lat device, this momentary button on here, so you wouldn't need to click twice. You can just click it once. I guess an expansion to that is I could do that to the clock, add this to the clock. So instead of having to click it twice for a full cycle, you can just click it once, but then it wouldn't really give you the inference of the actual clock, which has a low and high cycle. So let's go ahead and turn this on here and show a demonstration. So let's enable it first of all, like like a microprocessor would. Let's say we select the adding function for the processor to do. So turn that on. Let's add in the number 001. Again, it's right to left, least significant to most significant. And let's input that. So serial input will have low. So I'll just act like there's zeros going in. 1 full clock cycle 0, second 0, now 1. Now let's put in 101, which is 1 plus 4 is 5 decimal, plus 4 would be 9. And let's leave this high. Now it's low. Now it's high. Now the key is this. I'll flip this low. We need 3 more full clock cycles for the first number, which is in Z2 to Z0, and the second number right here, FF2 to FF0, to fully add together. 1, 2, 3. Now let's see, 4 plus 5 is 9 deci, and that's 1001 in binary 4-bit, right? This and this. And that's pretty much it. I've answered the various questions on discussion here, which you can read up more on, about defining registers, various methods to roll in. This is a serial versus a parallel in or out, or a rotate, or a universal register. Oh, here's the clear function, that it goes out, so that's good. What else? Advantages of an on and off switch. So this is what this is essentially. What's cool is if this is off, then somebody can't mess with it. So let's say in the real world you want a microprocessor and do another process, it's not going to be able to get into here. Differences between adder and sequential and combo is combo would be instant. Sequential, you have to go through this clicking process to go through. So there are pros and cons of each of those things, right? Sequential, you can kind of store it in here when you click this off, and it can't be messed with. Combinational is instant, but it will go away once you go away from it or change it. The data path control model. So that is here, you can see this is the data path side because you have the input, the data, and then the output. There's no control. I'm the human controller manually. You would have to build something to automate this. It would contain like some flip-flops, probably a demux or a mux and a decoder to run this through like we did in this next module for the full microprocessor. There's the building a house anecdote. I answered with a cooks at a restaurant anecdote where you can consider the server as the person who comes in as the control and external signal for the chef to make a certain thing, and then they go and grab in storage. That's a good anecdote. In their refrigerator storage and tools in their drawers to create the food. Then they output, and then they signal to the server out there that it's done and it's given to the customer. That is my 3-bit serial adder. Thank you very much.